squares. Or we could also have the sum or difference of cubes, and we're going to talk about that a little bit today. So this are higher power or higher degree polynomials. So I'm going to teach you how to factor those. It's a nice little pattern that exists every time if it's a sum or difference of cubes. Just like the pattern for difference of squares is just a little bit different because it's cubes. Okay, so all of those things are going to come up as we go here, and we're just going to start with higher power polynomials, something with not a quadratic, but all of those things with quadratics are part of this because our job is to factor completely. We want to factor it completely. So first example, x cubed plus 2x squared minus 15x. Start with a fairly easy one. Is that in descending order? Yeah, it's good in descending order. Is our greatest common factor across the entire problem? X. So we pull an x out first. That leaves us x squared plus 2x minus 15. And then we look at the parentheses and say, can I factor that any other way? Well, there are 3 terms left in parentheses, so that would tell me I need to try what method? X method. So multiply to be negative 15 and add to be positive 2. Are there any numbers that do that? 5 and negative 3. 5 times negative 3 is negative 15. 5 plus negative 3 is positive 2. So that does factor. Can I use the shortcut on factoring that one? Yeah, because the leading term in front of the x squared is 1. That allows me to use that shortcut. X plus 5, x minus 3. Don't forget the GCF that we pulled out at the beginning. And we factored that higher degree polynomial completely out of that. So, and well, technically two steps there. Get there. Let's try this one. 2y to the 5th minus 18y to the 3rd. In descending order? Yeah, good. GCF. Anything else? 2 is also in common, so 2y cubed. What's that going to leave in the parentheses? Minus 9. Y squared minus 9 we know is a yeah, we can do this difference of squares because 9 is a square number. It's 3 squared. So that means our factors would be what? Yeah, y plus 3, y minus 3, and then 2y cubed that we pulled out at the beginning. Let's start first, okay? So not too bad. It's not extremely strenuous, but it does require us to remember a lot of our other stuff. So let's try this one. I'm just going to the side there. 4x to the 4th minus 16x cubed plus 16x squared. Descending order, check. GCF. 4x squared. So we'll pull that out to the front. That leaves us x squared minus 4x plus 4. And we're going to try to factor that using the x method. It's got 3 terms. Multiply to be 4, add to be negative 4. Negative 2 and negative 2. So can I use that shortcut on the factoring there? Yeah, so it's x minus 2, another x minus 2, and then the 4x squared. Or we could write that 4x squared, x minus 2 squared. Either of those ways would be absolutely fine to to write that. Bless you. It's got the sniffles today. I think the burning of the pine needles didn't help either out there in the front. So, all right, let's get into that thing that we haven't done. That sum and difference of cubes. Okay, sum, difference of cubes. We'll do the sum first. All right, so the idea of a sum of cubes or a difference of cubes is similar to the idea of the difference of squares method. The idea is that you rewrite the problem as something cubed plus something cubed for the sum of cubes minus if it's a difference of cubes, right? So the way that if you can rewrite the problem to do that, then you will have a short factor and a long factor, okay? Always. The short factor will be whatever is cubed plus the other thing that's cubed. So if it's, here we got x cubed, it'd be x in the front, and maybe this is 27 here, that's 3 cubed. It'd be x plus 3. So this would be a plus b. That's the short factor. The way I kind of remember that is the short factor is the same. The S and S there is how I kind of remember that. The short factor is the same. If we kind of relate that to the difference of cubes as we're going here, if it's the same, well, it's going to be a minus sign in the middle. It'll be a minus b on the short factor. Okay. All right. Now the long factor is the leftovers. Okay. How many a's did I use out of this? 1. So there are how many left? 2. So that's a squared, right? The b's, I used 1 of them, right? So there's 2 of those left. I'm gonna put that down here at the end. Now we got a middle term because it's a long factor. The middle term is you multiply a and b together, and you put a minus sign there. You will memorize that pattern. It goes just like that: a squared minus ab plus b squared. On the difference of cubes, everything is on the long factor is a positive. So it's a squared plus ab plus b squared. Opposite sign in the middle on the long factor. It's a sum, it's going to be a minus in the middle. The difference is going to be a plus in the middle of the long factor. Long has an O in it, opposite has an O in it. So that's how I kind of remember that. All right. Let's look at some with numbers in it so we can actually do some of these, okay? X cubed plus 8. Pretty common one. It's got 2 terms. It's in descending order, so that's what triggers me to even look at this. And because it doesn't have a squared or a 4th power on it, that's what tells me, hey, this is maybe a difference or a sum of cubes. It'd be a sum of cubes here because we got a plus sign in the middle, right? Well, the key is rewriting it as a sum of cubes. Well, the first part's easy. It's x to the 3rd power, so that's just x. What cubed gets me 8? Bless you. 2. So the first part's x, second part's 2. So that's your a and b from the pattern that we talked about just a second ago. Okay. So your short factor is going to be x plus 2. Remember, the short factor is the same. It's a plus sign in the middle. It's going to be a plus sign in the middle. Okay. All right. The long factor. We use one of the x's. There are 2 left over. That's x squared minus x times 2, which is 2x, plus 2 squared, which is 4. You factored that. The long factor will never factor further. So that's the factored form. If you memorize that pattern, factoring them is easy. Okay. No big deal, actually, right? Let's say we had x cubed minus 27. Good one. It's a minus sign in the middle. It's two terms. The variable has a cubed on it, so that's what tells me, hey, that's a difference of cubes. Possibly. May not always be that, but you've got to be able to rewrite it like cubes, right? So the first part's easy. It's x cubed. 27 is what cubed? 3. 3 times 3 times 3 is 27, so that's why it's 3 cubed. If that were a 24 there, then it wouldn't factor because that 24 is not a cubic number, okay? Because it's 27, it's 3 cubed, it does factor using the pattern for difference of cubes. Short factor would be what? X minus 3. Short's the same, x minus 3. Long one. Good job. It really is that easy, guys. Especially when there's nothing in front of the x cubed. All right. So let's put a number in front of the x cubed, make it harder. Say we had 27x cubed plus 64. We still have to look for all those things, descending order, GCF, all those things we still should have to look for those. There just happens to not be any for these three that we've done so far, okay? So what cubed is 27x cubed? 3 and then an x. And then what cubed is 64? 4. And as you do more of these, the more experience you have with the cubic numbers, the more of them you'll have memorized. No, hey, that's easy. All right, so this is a sum of cubes. So we know we got a short factor, long factor. The short factor is the same. So it is super easy, 3x plus 4. Long factor. The only one I don't agree with is the front one. Not 3x squared. It'd be 3x times 3x squared. So like what I mean is 3x squared when I say that. So that's 9x squared. That's what that'll be. Yeah. Because if I do distributed property, this 3x has to multiply to be the 27x cubed, right? So that's why, the 9's got to be there to get that 27 back. And then there's the difference, or sum of cubes there, the factoring. And again, that long factor won't factor any further. If it's a sum or a difference of cubes, the long factor will not factor further. Say we had 8x cubed minus 125. Does that work to be a difference of cubes? I'm going to try. Is 8 a cubic number? Yeah, it's 2x. 125. 5 times 5 is 25. 5 quarters is $1.25. So that is 5 cubed. So we got a short piece and a long piece because we know it's a difference of cubes now. Short piece is 2x minus 5. The long piece, 4x squared. How much? Not 10x squared, but just 10x. And then plus 25. 5 squared is 25. Now here's a relationship between this and what we just took a quiz over, the division. If you have trouble getting a long factor out of that, you can do it. And most everybody that ever has any trouble with sum or difference of cubes, they always get the short factor right. And it's the long one that they maybe mess up on. If you, for some reason, have trouble with that, you can do division with the short factor into the original problem, and the quotient will be that long factor. Always. That's what factoring is. It's another way of dividing something apart. We just have some techniques that make it a little cleaner than long division does or synthetic division does. That's what factoring really is. It's dividing something into equal, into parts there. All right. Let's look at another one. So I'm kind of just going to mix stuff back in here. So 2x to the fourth minus 54x. What do we know about that? It's in descending order. That's good. GCF of what? X?
And 2.
And 2, because 2 goes into 54. 54 is even, so I'm going to pull out a 2x. What's that leave in the parentheses? Which we know already is a what? Difference of cubes, because we've already done that problem. Okay, so we know that that's going to factor as x minus 3, x squared plus 9x, plus 3x plus 9. And then we have the 2x from the beginning. Technically, this is what's happening there. So this is the 2x that was the GCF needs to be out in front of that too. So there's a combination of GCF and then a difference of cubes out of that. All right. Still just factoring completely. Nothing has changed as far as the instructions go. X cubed minus 3x squared minus 16x plus 48. We're pretty sure that's not a difference of cubes or a sum of cubes, right? It's too big. It's got too many terms. How many terms does it have?
4.
4. Is it in descending order?
Yes.
GCF?
No.
No. So if it's got 4 terms, what's our method for factoring? Grouping. Okay, so we group first 2 together. What do we do from there? How do we do grouping? Pull out the greatest common factor of the first 2, which is x squared. That leaves what in parentheses? X minus 3. What the second 2? Pull out a negative 16. X minus 3. So we get x minus 3, x squared minus 16. If you stop there, you're wrong. And we got another factoring that can be done here. This is a difference of squares that we could work with. So we know that that's going to be x plus 4 and x minus 4. And then the x minus 3 that we already had. That is taking that larger polynomial and factoring it completely. Back quarter 3, we were taking something starting with this and building that larger polynomial. I told you we were going to go backwards with it here, and that's what we're doing. We're working our way back to doing that. So 4 terms, grouping, GCF. Always look at your factors once you get one step of factoring done. Look at what's there and say, can I go any further? Because factoring completely is what our job is during this stuff. So look for that. Let's look at some exceptional ones that take a little bit of maybe higher level thinking to get to. X to the 4th minus 7x squared plus 12. So if it's quadratic, we really know what to do. If it's x squared and plain x in the middle and then a number. But going through the steps and the rules of factoring, you've got GCF, it's got to be in descending order. Then you do GCF, and then
you look at the number of terms. So this one's obviously in descending order. Is there a GCF? No. How many terms does it have? 3. What method do we use when there's 3 terms? X method. And this one works with X method the same way. It's just got x to the 4th and x squared in it instead of x squared and plain x. So we're still looking at it the same way as we would a normal quadratic that we did in Algebra 1, but we got x squareds and x to the 4ths instead. Okay, so what goes on the top of the x? 12 needs to add to be -7. -4, -3. Now, technically, you could do a shortcut here. I think it kind of shows a little bit better if you don't. Remember when we did grouping before you learned that shortcut for factoring a quadratic, you always replace that middle piece with those 2 sides on the x there. So this would be -4x squared minus 3x squared. So in the middle term, we're replacing, and they're both have the x squared on them because that's what the middle term had. Right? And then it's got how many terms in it now? 4, which allows us to do the grouping for those. So GCF of the first group would be x squared, leaving the x squared minus 4. GCF of the second group would be -3, leaving the x squared minus 4. So we have x squared minus 4 and x squared minus 3 as the factors for that. Will either of those factor further? That x squared minus 4 is a difference of squares. So it's x plus 2, x minus 2. And then the x squared minus 3 is not a difference of squares because 3 is not a square number. So you can't go any further with that. And that would be the factored form for that polynomial. So a higher degree polynomial, but still using the x method to factor it is the strategy we're using there. Let's look at another one of those just to kind of reiterate that. 6x to the 6th plus 16x cubed plus 8. What can we do here? 2 is a GCF, so that'd leave us 3x to the 6th plus 8x cubed plus 4. This has x to the 6th power and x cubed. Ugh. But it has how many terms in it? 3. So that tells me, hey, I should try the x method on that because it has 3 terms. The rules for that are how many terms it has, not necessarily what kind of terms it has. Okay, 3 times 4 is 12. And something multiplies to be 12, adds to be 8. 6 and 2, and I can't use a shortcut here because I got something in front of the leading term there. So I'm going to go 3x to the 6th and plus 6x cubed this time because the middle term has x cubes. So my replacements should have x cubes. Okay. Plus 2x cubed plus 4. And then I'm going to group that. So 3x to the 6th and 6x to the 3rd have what in common? 3x to the 3rd, leaving x cubed plus 2. And then the other one, the second pair has a GCF of 2, leaving x cubed plus 2. So we have the 2 that we factored out at the beginning. We have x cubed plus 2. 3x cubed plus 2. We need to look at those to see if they could factor any further. So x cubed plus 2, is that a sum of cubes? No, why not? 2 is not a cubic number. If this were x cubed plus 8 or 27, 64, 125, any cubic number, then we would go further. But it's not, so we stop there. Is this one a sum of cubes? No, 3 is not a cubic number. We already know 2 is not. So that's the factored form for that one. Okay. What's the point in all this factoring? It makes it easy to solve. Okay, that's the idea. When we were doing quadratics, to solve it, what'd you have to get it equal to? 0. Okay. Same thing with higher degree polynomials. You had 4x to the 5th minus 20x cubed plus 36x, and it's equal to negative 20x cubed. Not negative 20x, positive 20x cubed, sorry. What can you do with that? Why are you doing that? Yeah, so the main focus here is to get 0 on one side of the equation. If you get that, then you're ready to factor. Just so happens that we've got like term over there. Doesn't necessarily matter if it's a like term or not, but it happens to be for this one. So we get 4x to the 5th minus 40x cubed plus 36x is now equal to 0. So we have something, a trinomial. It's got 3 terms. But we follow the rules of factoring just like before. So first step, pull out 4x because 4 goes into itself, 4 goes into 40, and 4 goes into 36, and they all have an x on them. So what's that leave in parentheses? Plus 9. All right. Now we got a trinomial left in the parentheses, so we want to try to factor that. It's got 3 terms, so that means we use what method? X factoring method. So multiply to be 9 and add to be negative 10. Negative 9, negative 1. My shortcut I could use because there's nothing in front of x to the 4th. What would the factors be if I use the shortcut? X squared minus 9, x squared minus 1. I still have that 4x there. What do I know about x squared minus 9? It's a difference of squares. It's x plus 3, x minus 3. What about x squared minus 1? Is it a difference of squares? 1 a square number? So yeah, 1 is a square number. So it's x plus 1, x minus 1. Hey, 1, 2, 3, 4, 5 factors out of that. That's a lot. But how do you get the answers from factors? Set each individual one equal to 0. 4x equals 0. X plus 3 equals 0. X minus 3 equals 0. X plus 1 equals 0. X minus 1 equals 0. Set each of those equal to 0 and solve them. There we get x equals 0, x equals negative 3, x equals positive 3, x equals negative 1, x equals positive 1. What was the degree of the original polynomial? What was the 5th power? That's the highest exponent. That means I should have how many answers? 5. Whatever the highest power is, that's how many answers you should have. And we found 5 by factoring. Okay. We're going to find some other methods to use later on after spring break, but that idea is exactly what we want to do here. Let's look at one more. Last one. Negative 27x to the 3rd plus 15x squared is equal to negative 6x to the 4th. A lot of numbers in there. If we're going to solve an equation, we need to get it equal to what? 0. What's the quickest way to get this one equal to 0? Yeah, move the 6x to the fourth. Does it have a like term over there? No. Where should it go? Y to the front. Descending order. So we got 6x to the fourth, 27x cubed, 15x squared equals 0. Now what? 3 goes into 6, 27, and 15. How many x's they have in common? X squared. So 3x squared is your GCF. And then we have 2x squared minus 9x plus 15 or 5. 15. What about this part? X method is what we're going to try. 2 times 5 is 10, and I had to be negative 9. 10 and 1. That has to be 11. Negative 10, negative 1. That has to be negative 11. 5 and 2. 7. Negative 5, negative 2. Negative 7. Close, but not right. Does that factor? No. Can we still solve it?
Yeah, you can set that equal to 0.
Right. We can set, we're going to set each of these factors equal to 0. 3x squared equals 0. And then 2x squared minus 9x plus 5 is equal to 0. The left one here, divide by 3. 0 divided by anything is 0. And then we take the square root of both sides. Right? Plus or minus on that side, technically. But the square root of 0 is 0. That counts twice because it came from an x squared. So when we start counting up how many answers we got, this 0 has what's called a multiplicity of 2. That's what the word is for that. Multiplicity of 2, because it came from an x squared. That's the reason it counts twice. Okay. All right, and then how do we solve that if it won't factor? Quadratic formula. Okay. X equals negative b plus or minus radical b squared minus 4ac divided by 2a. So a, b, and c, x squared, or 2, negative 9, and 5. So plugging those things in to work this out. So 9 plus or minus. I'm going to go over here and do the discriminant. Remember we talked about that? Negative 9 squared minus 4 times 2 times 5. So that's 81 minus 40, which is 41. Square root of 41 is in there. 2 times 2 is 4. So we get two answers there. We get x is 9 plus the square root of 41 over 4. We get x is 9 minus the square root of 41 over 4. Let's get the decimal approximation for those as well. So these are the exact answers. That's what I prefer and what I'll ask you for. But let's go ahead and get the decimal approximations because we're going to need those later on when we start doing some graphing and things. So 9 plus the square root of 41, not 40, 41, then divided by 4, 3.85, just going 2 decimal places there, and then 9 minus the square root of 81, or 41, sorry, divided by 4, negative 0.6 or 0.65. So 1, 2, and remember this one counted twice, 3, 4. The original degree of the polynomial was 4. That was the highest exponent. We had 4 answers to a degree 4 polynomial. Always going to have that, okay? All right. That